welcome to the course Design Practice lecture module 33. From the previous lecture modules, we are discussing about design of a work system. In a previous lecture module, we have already covered the basics of work system, that are the elements involved in a work system design, and job description, what are the approaches to job design, and what are the method analysis which you can perform for a designing in your job in a work system. Okay. In this current module, I will discuss remaining topics for this work system in design. Okay. Now, I will start covering the motion study. What is the motion study? Motion study is the systematic study of the human motion used to perform an operation. In previous module, we have already learned method analysis. In that analysis, what we did? We performed operation of an product in a structured manner. Okay. So, this analysis helps in a structuring of your operation. Okay. Now, in a motion study, you are focusing now on the human motion used to perform an operation. Again, it is a type of making a chart in a process for a work design, but in a different way. Here you will also count time and your graphical representation in a more detail, because in method analysis there were only 5 symbols which were used to design a work system. Okay. Here you will get variety of representation to represent your operation in a more elaborate way. Okay. So, there variety of techniques are already available in a motion study. So, motion study are the first technique: motion study principles, analysis of thermalics, macro motion study, and charts. Again, charts is also available here for in a motion study also. So, motion study principle, it guidelines for designing motion efficient work procedure. This is the for standard guidelines is available. For motion study. Analysis of thermalic. Thermalic is a set of graphical picturization of your operation and various movement, so that from using this you can make a graphical representation of any process or operation. It basic elemental motion into which a job can be broken down. Okay. In this analysis, a job is divided in a several parts, and each part is represented with a unique graphical picture. Okay. Here in a macro motion study, use of motion pictures and slow motion to study motion that otherwise would be too rapid to analyze. Okay. In this study, what happens? Each operation is recorded at a very slower rate. Okay. Continuous images, each frame is recorded for a certain operation. Suppose that your hand is somewhere here and you want to move it from there. So, okay, and you are taking one product from here to this one. Okay. So, whatever path you are following to reach this product to that point B, so those image path is recorded in a camera, and multiple continuous picture is recorded, and after that each picture is analyzed to see what is the actual time is required to transport this part to here from point A to point B. Okay. And also charts is also available for a motion study. Okay. So, I will explain method of thermalics first. So, here fundamental hand motion, that is thermalic analysis also called hand motion. Okay. It is a system of symbols that represent every elementary of hand and arm and eye movements. The word thermalic was first proposed by Frank Bunker Gilbert and Lillian Moeller Gilbert. So, respect of those people, these hand motions is known as thermalic. Okay, there are three category of thermalic. First is motion required for performing an operation. So, in this category, what are the motions which is required to performing an operation? So, each operation will have some specific graphical symbol. Here there are variety of motions which is required for performing an operation. First one is transport empty, grasp, transport loaded, carry, position, use, assembly, deassembly, release load, inspection, etc. Here that is the one graphical. Here you can say that if you are placing a one paper in this box, so you will have to perform various operation. Second type is motion that tend to slow down, type 1 motion. Okay. This one is related to search, find, select, plan and preposition. If you are searching something, so it will take time. So, what happens? Suppose that you are transporting something from here to here, you have to transport one product from one place to another place, and somehow you have missed that product where it has placed. So, you have to make a search for that product. So, it takes time. So, what happens? It slows down your motion, okay, of transportation motion. Second one is find, selection, this takes time. And third one is motion that do not perform an operation, at the hold, unavoidable delay, rest. Okay. These are the motions which is for permanent, you can say storage or delay kind of thing. So, it slows down it just stops down the operation. Okay. Suppose that if there is an unavoidable delay in a workshop, so you will have to stop everything, your whole operation will get stopped there because of this one. Okay. So, each operation has some specific symbol, that is called thermalics. Here you can see, here thermalic, if you are searching something, so there is a color coding with that. Okay. So, that a worker can understand here you will have to make a search of that, something like that. So, there is a symbol for search operation. Again find, so its a color is gray, and find there is a unique symbol for find. Select, grasp, hold, transport loaded, transport empty, position, blue color. If you are assembling something, so hash line. If you are using something, so its color code is purple, and color code may vary to industry to industry. It is not strict to that if you are making a disassembly. So, but yeah, in most of the cases these are the standard color coding. So, everybody can understand, so that the color is most probably these colors also is there for this motion study. Okay. You are disassembling something, the symbol will be like this one, inspection, this one. So, they are the various operations, and each have a specific color code with their symbols. Okay. And these symbols and color code is used in a motion study. We will use in this chart, that is called simultaneous motion cycle chart, that is called SIMO chart. Here we will use those thermalics to make a SIMO chart. What is the SIMO chart? It is a chart often based on film analysis used to record simultaneously on a common time scale the thermalic or group of thermalics performed by different parts of the body of one or more workers. Okay. Here is a kind of film analysis. So, first film is recorded, and all job is broken in various part, and each part is assigned, operation is assigned using a thermalics, and we will explain in a table. So, time scale is represented in a wink, and a wink is a 1:200,000 of the minute. Okay. That is the time scale in a SIMO chart generally used. Okay. And the SIMO chart is the micro motion form of the main type flow process chart. We have already discussed main type flow process chart in a previous lecture module. Because SIMO chart are used primarily for operation of short duration, often performed with extreme rapidity, it is generally necessary to compile them from films made of the operation which can be stopped at any point or projected in slow motion. So, if you are doing film analysis, so you can stop your recording any time, and also if you want to analyze in a detail, so that you can slow down your video, so that you can analyze in a more detail, analyze the more detail your operation. Okay. What are the basic steps for SIMO chart? Step: see motion made by operators right and left hand. So, okay. So, first what is happening, using the video recorder, motion of right and left hand is recorded. After that, notice what the finger of each hand do. After that, each finger's movement is get noticed. After that, detect where one motion ends and another begins, so that you can count the time. Judge the length of motion, estimate time of the motion. Okay, length of the motion and time, estimate time of the motion. After that, you will have to fill that table for a SIMO chart. This is a one standard chart for a SIMO chart. That is, you will have to mention drawing number, name, film number, chart number, sheet number, date, who made this chart, who is approved this chart, operation number, component name, name of the operator. Okay. And here you can see that left hand description, whatever your hand is doing. Suppose that in a you have already seen in last previous module, here we had in a two-handed chart. Here we used both handing, we recorded operation of both handed using a 5 symbol. Here what you are doing, you have make a video of your operation of your both hand, movement of your hand, then you just breaking all the operation in a various part, and whatever you are after distinguishing left hand and right hand, then you will have to make symbol for each operation whatever you are doing by your hand, and that what the time is required for that operation. Okay. And it is in wink form. So, wink is 1/2000 minute of a 1 minute. So, this is the example filing of workpiece. Here again these things should be fulfilled first: department, film number, what is the operation, charted by date, operator. Here you can see that after recording of video, so you have already distinguished in a distributed all your operation in a left hand and right hand. Here you can see searching and lifting workpiece. So, what is the thermalics is used, SH and H. Here again what is the what was the time for that operation, 400 wink. Again clamping workpiece in vise, we again do the hand filing operation, check the dimension, remove the workplace. So, again you have here parallelly you are using thermalics and you are recording the time, okay, using your film analysis. So, this is called SIMO chart. Here both thing thermalic and time is available for analysis. Now, film analysis, how film analysis is done. That is concept: record movement of a working operator with an appropriate film technique, then list all the observed motion and time employed into an analysis sheet. Okay. That is the thing I said in earlier slide, that first you will record whole operation, then you will break it in a various motion, observed motion, and then you will have to calculate time. That is the whole complete process for the film analysis. So, these are the film production methods are available: macro motion, memo motion, cyclographic, chronocyclographic. Macro motion is the slow recording of a operation, cyclograph, chronograph. I will explain some of them in next slide. Now, cyclograph, this is the film analysis video recording techniques. Cyclograph, it was introduced by Gilworth first. It is a photographic record of the path of the movement of the operator doing a job. Here what happens, little source of light is attached to the hand of finger, any other body part, whose motion are to be analyzed. When he or she performs the operation and photograph is taken continuously, the path of the motion is recorded on the film as continuous streak of light as shown below. Here you can see that here suppose that you have started working from this point, okay, and you have done several kind of things here in suppose that each point, this is the main path you have followed to complete that process, okay, and camera is one light bulb is attached to your finger or some or your you can say your hand, so that this path is recorded, okay, and this is called cycle graph. Okay, whatever you path you have followed, it is recorded in a camera. Okay. So that after that, suppose that here a variety of suppose that x number of operation you performed. Okay. So first what you will do, you will break operation into x1, x2, x3, x4, you can write here x1, x2, x3, x4, x5, x6, like that. Okay. Then after, suppose that here from x1 to x2 whatever you have done, so this will you will have to make, if you are making CMOS chart, then you will use Therbalix symbol, and as well as what is the time required from this operation to this operation. Okay. So everything you can analysis after recording this cycle. So this is called known as cycle graph, and this is very useful method in a motion study. Second one is chronocycle graph. Here it is a special type of cycle graph in which the light source bulb is suitably interrupted electrically, so that the path of the motion in the photograph appears as series of pear shaped spot instead of continuous streak of light as shown in below. Here this is the different from cycle graph. Here what you are doing, your just you are making shadow of light, you are using shadow concept. Okay, in which the light source is suitably interrupted electrically, so that path of the motion in the photograph appears as series of pear shaped. So if pointed into the pear shows the direction of movement. So this point, suppose that this is the actual shadow light. So this is the point direction. So it shows the direction where from where you are moving your hand from here to there. Okay, and length of this one, it denotes the time, it is calibrated by time. So whatever, if length is more, then suppose that if length is more, then that time required from for this operation is higher, and a more elongated and spaced pear spot indicate higher speed of operation. Also time as well as speed is very high, because here you can say that the width is higher as compared to here, and length is, so here speed you have moved, speed is higher, you have moved your hand rapidly in this spot, this area, as compared to previous one. Okay. So now it helps in studying the complex and restricted motion also. Okay. So that if suppose that somewhere is a it is very difficult to for your hand to make a recording that is by camera, that is attached to your finger. So this technique is very useful, because it's make a shadow light, it technique of shadow light, so that shadowing anything can be possible. Okay. So restricted motion can also be performed using chronocycle graph. Now after recording of your images, then you can make a CMOS chart for your motion study. Now I will explain now third step of your work system design, that is the after method analysis and motion study, then this is the critical examination. Suppose that if you have prepared already a chart, then how you will have to judge it, critical examine it, whether you have made it actual go in a actual way or something wrong is there. Okay. So the fact recorded in the flow process chart are now examined critically by applying the various questioning techniques. So these are the one of the techniques which is for critical examination. Okay. Questioning technique is very primarily stage of your examination purpose. So here following sequence you will have to follow for examination purpose, for which the activity is done, then you will have to check which place at which the activity is done, then sequence, where sequence is followed properly or not, again person and means by which, because sometimes chart preparation is varied between person to person. Skilled and experienced person may be more suitable for your making a chart, and he will make more efficiently. Means by which, and what means you are making this chart. So these are the several questions you should have arrived in your mind while you are examining your chart. Okay. With the objective of eliminating, combining, rearranging, simplifying the activity involved in the process, questioning techniques involves primarily question, secondary question. Okay. So, this is the trial and error method. Suppose that you have made something, you realize that you have made wrong sequence in your chart preparation, then you can again you will improve your chart, then you will have to again you will follow these steps to for examination of your chart. Okay. So, in a broad way these questions are divided into two parts, primary question and secondary questions. What are the primary questions? According to questioning technique, the primary question are as follow: purpose based, what is actually done, why is the activity necessary at all. If you have found that this activity is not necessary, then you just eliminate it. Place based, where is it being done, why at this place. Okay. Sequence based, when it is done, why at that time. Person based, who is doing it and why by this person. So, these all parameter you just combine or rearrange, you can rearrange the things, so that your chart will get improved. Okay. Means based, how is it being done, why in that particular way. Okay. Suppose that you have made a good chart in a right manner, but in a complex you went through complex route. So, if this route can be simplified further, so that chart look better and understandable. Okay. So, these are the primary questions you will have to keep in mind while doing your examination, critical examination of your chart. Now, secondary questions. Secondary question, corresponding to each answer obtained through your primary question, further questions are raised to explore about the alternative. Now, if you after that, suppose that you have already examined your chart, then you will have to look for alternative, whether there are any alternative is available, and in whether it suppose that is there for you have made one chart and there is already alternative chart is already available in your workshop, and so it what will happen, just it will simplify, it will save your time and cost. Okay. This methodology makes use of secondary question given as follows. These are the secondary question. What else might be done? These are for alternative looking for. Where else might it be done? You can change your place. Suppose that you can't fix in a one place. Suppose that in a that place somehow work is not going on. Then how your production is will be continue. So, you will have to look for another place. When else might it be done? Who else might do it? Suppose that you have a one person, skilled person for a chart preparation, and he is on leave. So, who is the other person who is capable of doing this? So, you will have to take a one already backup for that. Okay. How else might it be done? By examining the primary and secondary question, we use the systematic critical examination in order to evolve a better method of doing that work. Okay. So, critical examination is always necessary for designing a work system. Now, I will explain the work environment. After making your chart preparation, job designing, now we will come to work environment. This is also a very important factor. Okay. Here working condition can affect worker productivity, product quality and worker safety. Temperature, ventilation, noise and lighting are all factors in work system design. They are the Congress passed OSHA in 1970 to mandate specific safety conditions that must be met. This is was proposed in USA, okay, for working environment. There are the some in these guidelines, there are some standard guidelines protocol is there for to make a working better work environment. Okay. So, here you can see that work environment quality. If there I suppose that you are working in a environment where temperature is high and humid. So, what will happen? Workers efficiency will get reduced because of that, because fatigue will be there for each worker. Okay. So, lightning condition, you can also say lightning, that is the working environment. Okay. So, better lighting condition required for proper visualization of worker. Okay. Suppose that a worker is assigned to work in a machine and and lighting is not proper. So, he may face some accident, so that he may get injured. Okay. So, these are the very crucial factors which is involved for a in a work, and you have to take consider in a work design. So, work environment is also necessary part. Now, work measurement, after your designing your machine method analysis, motion study and designing of taking consideration of work environment, then you will have to consider you have to technically measure work measurement. Okay. So, work measurement, what you will have to measure the effort of your workers, so that you can grade your worker, okay, or your process, or you can, if you want to measure your productivity of your system, then you will have to measure it. Okay. So, work measurement helps determine how long it should take to do a job in a standard way. Suppose that a one worker is doing something on machine, okay, and if you want to calculate what is the machining timing, suppose that, so you will have to measure how much time required to complete the one process. Okay. So, involve determining standard time and standard time for each one, for job, for process, the length of the time a qualified worker using appropriate process and tools to complete a specific job, allowing time for personal fatigue and unavoidable delay. Okay. So, you will have to take all consideration in personal fatigue, unavoidable delay, idle time in a calculation of standard time. Okay. Till now, we have already learned through in a work system design, where we learned what are the elements to be followed in a work involved in a work system design, and what are the methods available to make a proper system, work system for your industry. Okay. Now, I am closing this module here, and in the next module I will cover some other topic. Okay. Thank you very much.